Hello. So our topic for starting topic for our finals will be mastering object-oriented programming in Python, wherein we will be discussing the concepts, principles, and practical applications of OOP. Okay. So introduction to object-oriented programming. So what is OOP? Okay, or um, we usually call it, or we term it as object-oriented programming. Okay, object-oriented programming is a way of writing programs by organizing code into objects. Okay, you may want to think of an object as a mini program that will contain, number one, you have your data, okay, which are called attributes. Okay, in a real life scenario, these are to be likened to a person's name or age. What else? And you have your functions. These are called methods, which are actions the object can do. Okay, like you have your walking, jogging, talking. Okay. Now, these objects are created based on classes, which are like blueprint or templates. Now, for example, if a class is like or like the idea of a car, okay, then objects would be actual cars that you can use. Okay, each with its own color, speed, and fuel level. Now, by bundling related data and actions together, OOP makes code easier to understand, reuse, and maintain. Now, what are the importance of OOP in modern programming? OOP or object-oriented programming is widely used in today's software development because it offers several key benefits. Okay, we have number one, modularity, wherein code is divided into classes. Okay, each with a specific role, and wherein it makes it, or this modularity makes it easier to find, understand, and fix parts of the program without without affecting the whole, okay, or the whole program. Next importance is reusability. Okay, once a class is written, okay, it can be reused in different programs. With this one, it saves times and avoids rewriting the same code again and again. Okay. Next, scalability. With OOP, it makes it easier to grow your application. Okay, you can add more features or handle more users without breaking the existing code. Encapsulation. Okay, data, data is kept safe. Okay. Data is kept safe inside the object and can only be accessed through specific methods. Now, this protects your code from accidental changes and bugs. You also have your real-world modeling. OOP helps developers design programs that closely represent real-world things like cars, users, or bank accounts. This could make the code easier to relate to and at least to design. Now, what are or we have here the comparison with procedural programming. Now, when writing software or writing a program, developers or programmers choose between different styles or paradigms of programming. Okay? Two of the most common paradigms are your procedural and the object-oriented. Now, let's just check some of their differences in terms of structure, code reusability, data and logic, and example languages. Okay. In For structure, for procedural, okay, in terms of its structure, the procedural programming, okay, are built using functions and procedures. These are your step-by-step instructions for the computer to follow. Now, while in your OOP, programs are organized into classes and objects, which group data and behavior together. Now, next feature or next category that we will be using as a comparison point is that code reusability. In procedural, code tends to be less reusable. Okay, if you want the same functionality elsewhere, what you will be doing is, or you often have to copy and modify that certain code. Now, while in OOP, okay, code is highly reusable, right, through different classes. Now, you can create new objects from classes or extend existing ones with inheritance. In terms of data and logic, okay, terms of data and logic, procedural or for procedural programming, data and logic are kept separate. Okay, wherein data is passed into functions. While on OOP, data and logic are combined. Okay, which are or they are combined inside an object, making the code more organized and closer to real life thinking. Now, for example, commonly seen in procedural are C and Pascal, while for OOP you have your Python, Java, and the C++. Okay. Now, what is a class and an object? A class, as shown in this presentation, it's a user-defined blueprint or prototype. Okay. When we say class, it's a blueprint for creating objects. Example, we have if you have a car, okay, it's a class, okay, wherein it will describe the features like the color, brand, and engine. Now, object object is an instance of a class. Okay, it usually represents a specific implementation of the blueprint. An example of which will be a red Toyota Corolla or a Toyota Vios. Okay, so that's an object of your class car. Okay, now what is init in Python? Init, okay, is a special method in Python that acts like a constructor. Okay, which means or meaning it automatically called right after an object is created from a class. Now, what does it do? Okay, what does this init do? Right? Its main job is to initialize the object's attributes. Right? Um, the data or wherein the data that belongs to the object. Right? You may think of init like when you build a toy. Okay, that's the object. Okay, using a mold, which is your class in that instance. The init, okay, method is like setting the toy's color, size, or shape right after it's uh, made. Now, the init or the lines before the word init and after the word init are actually double underscore. Okay, so double underscore, init, double underscore. Okay, here is the syntax for your class. Okay, you have your class keyword, then the class name. Then we define, okay, you have your init, okay, then the self, then the parameters. Okay, the first parameter will be always self. This refers to the instance of your class. Now, the other parameters are passed when the object is created and are used to initialize the object's attributes. Now, in terms of object, on how to create an object, we have here the object name equals the or object name is any variable, okay, that you choose to represent your object. Now we have here class name. It's the name of the class where you define or where will you be defining the object. Okay. Arguments. These are the values passed to the init method if it has parameters. Okay. So okay. So we have here your or an example. Okay, for a class car. Okay. Now, um, we have created here a class car, okay, wherein we start by defining the class using the class keyword followed by the class name car. Now, the first thing inside the class is a special method called init, okay, or the double score init double score. Now, so we have here your uh, init self brand color. Now, um, this is your constructor method. Um, it gets called automatically every time we create a new car object. Okay, it takes the self, brand, and color as parameters. So you have here self.brand is equals to brand, self color that color is equals to color. Then we assign the values of brand and uh, color um, to the object's attributes. Okay. In this case, you have your self.brand and self.color. Now, you might be wondering what is the keyword self. The keyword self here refers to the or to the specific objects being created. Okay. Then next, we will be defining a simple method that will simulate the car driving. Okay. So we have here your method drive. Okay. Or this method drive will just print out a message that will tell us, okay, which car is driving using the brand and color stored on in or in the object. Okay. Now, for the object, okay, for the object, we have we will be creating a car object, okay, which is called my car with brands Toyota and uh, tawag dito, So we have here the object, which is my car object uh, that we will be creating from your car class. Okay. Then the drive method will call the objects method to perform an action. Okay. Now, let's build an example of our class. Okay. Now, we will to create a simple Python class that will represent a student. Okay. So first, we will be starting by defining a class called student. So class student, okay, then colon. Now inside the class, we'll define the init method. Okay, this will serve as our constructor. So def init, then self name, then course. Now this init method will take in name and course as parameters. This will store the student's information when we create an object. Okay, so we will now be uh, creating, okay, what's inside of our init method. So self that name is equals to name. Self that course is equals to course. Now, um, we assign these values to the objects attributes using self, which refers to the current instance of your uh, class. Next, let's create a method to let the student introduce themselves. So we'll create a method def introduce. Okay, we're in self. Okay. Then wherein this introduce method will we would like it to simply print out a message with the student's name and course. So print I am self that name studying self that course. Okay. Uh, okay. Okay. Now, after which we will create a student object and see this in action. Okay, so student one is equals to student and okay. So we have created a student object, okay, named student one, which will pass the name Ella in computer science as the course. Okay. Then we call an introduced, or we will call the introduced um, method. Okay, wherein Ella should introduce herself. Okay, and there should be an output of Ella studying computer science. So let's try student one dot introduce. Save. Then let me save this. Okay. So student Sabiha, name error. Name student is not defined. S2 get student. Click. Uh, yeah. It's because of the indentation. Okay. I forgot that it should be uh, now within the inside the class, but or since we are calling now the or creating an object, okay, out of your class student, so it should be outside your student class. Okay, so save, then define. Okay, so just put space. Okay, so that's the uh, output. Okay, now another uh, example that we can provide is that we try to create a class bank account. Okay, so then we'll create the class bank account. Okay, now here we define the class name bank account. Okay, then inside we start with the constructor method. That's the init. Okay, so def init self owner. Then we put some a, balance uh, parameters. Okay, wherein this init method will take two parameters wherein we have your owner, okay, for the accounts holder name and the balance, which we will try to set it at a zero, okay, by default, okay, or the initial balance is at zero. Now, uh, we will create or we will initialize the object attributes, okay, the owner, which will store the name of the account holder and the balance that will keep the track of the current balance. So we have here self that owner is equals to owner. Then self that balance is equals to the balance. Now, uh, after which, let's try to add a method that will deposit money to the account. Wherein, okay, def deposit, okay, herein, in our deposit method, we will take an amount and it will add it to the balance. Okay, so we'll try to take any amount, okay, in this one. So self amount, okay, and we'll try to add it to the balance, okay, and print a confirmation message. So let's try. So let self that balance plus equals amount. Then print, sorry, amount deposited. Okay, so we'll just provide a confirmation message. So you balance is self that balance. Okay, so we have that one. Then let's now try to test our class by creating a bank account and depositing money from or into that account. So then, so we have account one is equals to bank account. So maybe the name will be Mark. Okay. Then uh, just in this line, okay, we created a bank account object that will be okay that we have named it as account one, okay, for a person named Mark. Now we will be calling the deposit method with the uh, maybe with an amount of 5,000, okay, wherein the balance should be updated, okay, and we'll check the message or